All right, we're live. If this is actually working, we'll find out. So the first thing I'm going to do is just part A from example 1. It's the most similar to question 1 in the problem set. And you can see my kid attempted to solve it. So a quadratic function is defined by g of x equals 2x squared plus 12x plus 1. Write this in completed square or vertex form and show all the steps. So I actually, move that real quick, put this on a whiteboard. Just thought it'd be more fun. So, and the reason I put aka vertex form for complete the square is because I don't want you guys to forget the point of completing the square is to see things that we couldn't see in the quadratic form. So when you complete the square, you get things like the vertex, and that's really the main thing. If you have your vertex, it's really easy to plot. So how do we complete the square for g of x equals 2x squared plus 12x plus 1? I'm going to grab some other colors. Alright, so we're going to focus on the 2x squared plus 12x, right? This is going to be the part where we complete the square. And we're going to leave the plus 1 out here. So we're going to add something here. I guess I'm going to put the plus 1 here, sorry. So we're going to add some number here. And in order to not change the equation, we're just changing the way it looks. We can't actually change the value of the equation. We have to subtract whatever number we add to the inside to the outside. Oops, sorry, I don't know why I put a 1, being silly. Okay, they're both in blue because they're the same. They're going to be the same number. Alright, so there's something we have to do here before we complete the square, and that is pull out this 2. Okay. So we end up with 2. And that leaves us with x squared plus 6x plus whatever our number is to complete the square. And then on the outside here, we still have our plus 1 minus whatever our number is to complete the square, and then times 2. Because technically the number we're adding in here, I'll zoom out a little bit, sorry. There we go. Alright, technically the number we're adding in here is multiplied by 2. So we have to remember to put that 2 out here. And we've done this before in previous lessons. This is a recap. Alright, so if we look at the number that we need to complete the square, it's half this squared. So 3 squared. And I like to leave it as 3 squared initially, just because it looks a little bit nicer when you actually write the completed square. And since we have done this in previous lessons, I'm not going to dwell on it for too long. Plus, let's see, 1 minus 9 times 2, so 1 minus 18 would be negative 17, right? Okay, and this, let me put it in purple. So here we have our, let me see all of it. Here we have our completed square. So that's all you have to do for the first problem in the homework. So I'm going to leave it at that. Okay. Now we're going to move on to an example that's similar to problem 2. Okay, put this down. Bring this guy back up. Get a little closer so you can actually see what I'm doing. Okay, so even a little closer. So for this one we have a parent function, and that's the whole point of this lesson, right? We're talking about the parent function x squared. So what transformations do we do to this here? Well, we know what transformations we do, but what does the function look like after we do these transformations? So 3 units to the right. Let's look at that one first. We'll name our new function, since we have f of x, let's name our new one g of x. You could have named it whatever. Maybe your name is Ronnie, so you named it r of x because you thought that was cool. All right, so if we're moving it to the right, we know that affects what's happening to the x directly. So, in parentheses, x minus 3 squared. And that's because when you shift to the right, you do a negative sign. All right, a vertical shrink by a factor of 0.5. So this one always gets me a little bit. And sometimes I like to double check it on Desmos. So we'll go ahead and do now we're going to change g of x again. So shrinks are the number in front of it is how it affects it. So if it's shrinking by 1/2, we multiply it by 2, which sounds a little weird, but that's just how it is. If it's shrinking, you multiply it by 2. And if you're having trouble visualizing what transformations look like, you can always go to Desmos and just start plugging numbers in. It's a really good way to get comfortable with transformations. That's what I do. Because I do it sometimes, and I still sometimes have to double check, second guess myself, you know? All right, so now we're flipping it, we're reflecting it across the x-axis. That's the horizontal axis, which means all you do, this one's the easiest one, you just put a negative sign. Okay. And then we're, last but not least, I'm out of colors, so I'm going to go back to green. Actually, I'll do purple. Last but not least, we're shifting it 4 units up, which means that we add 4 to the end here. Not too bad. Okay. Now we're supposed to graph the parent function and the transformed function on the same coordinate plane. So I'm going to try and zoom out so you can see the equations, but also the graph. Okay. So I'll make my x-axis here, and my y. Whoop. Not very well. I should have used a ruler, which I have somewhere. Okay. And we'll just go ahead and say each of these is worth 1. So 1, 2, 3, 4, 5. I like to mark it where the 5 is, just because then it's out of the way. You can see what the scale is that way, but you're not in the way. Like a lot of the times you have to do stuff around the origin. So if you mark it at 5, you're sort of marking your clear points out of the way. So let's go ahead and do the original graph in, I guess the color doesn't matter that much. We'll do it in purple. Okay. So, x squared is a parabola. It starts at 0, 0. You can think if we had, just plot a couple points, you know, if we had -1 as our x, then 1 would be our y. If we had +1, we'd have 1. If we had -2, we would have +4. If we had +2, we would have +4. And just because we are graphing an original function and a new one, it's kind of nice to have it to scale. So 5, 6, 7, 8, 9. So there's 9. So if we had 1, 2, -3, we'd have +9, +3, +9. Boop. Not my best parabola, but not my worst. So this is our function f of x equals x squared. All right, and I'm going to graph the new one in green, our g of x. So let's see. So now we have a vertex of 3, 4. So 1, 2, 3, 1, 2, 3, 4, right? And if you're kind of curious on new points, you can always plug something in, right? So I like to do something on either side of it. So since our starting x value is 3, I'll do, I'm going to go ahead and do 2. So what happens when I plug 2 in? Well, let's see. We have 2 minus 3. 2 minus 3 is negative 1. Squared is 1. 1 times negative 2 is negative 2. Negative 2 plus 4 is 2. So 2, 2. And you can draw a table. If you're not great at doing this in your head, draw a table or use your calculator. I'm just doing it in my head because we've done tables and we've done calculators, so I sort of want you to see my thought process doing it this way. So, and then if we go to the other side of 3, we have 4, right? Okay, so 4, and let's go ahead and plug that in. 4 minus 3 is 1. Well, we know it's going to be symmetric, actually, so it's going to be here. Okay. And let's see, it was a vertical shrink, so it looks like since it was a shrink, it does look like it's going to pan out. We could do another point over here, but I'm going to go ahead and just do that. So let's see if everything looks right. Let's double check our work. So did it shift 3 units to the right? Let's see, 1, 2, 3. Yep. Did it shrink by a factor of 1/2? Well, it's thinner, so yep, seems about right. That's the hardest one to tell just by looking at it, but we know that our numbers are right. Did it reflect across the x-axis? Well, it was above, going up over it. Now it's going under, so yes. And did it shift 4 units up? So let's see. Vertex, 1, 2, 3, 4. Yep. All right, pans out. And that's similar to problem 2 from your homework. Okay, last but not least, something that is similar to problem 3. Sketch the graphs of the following functions based on the graph of the original function. So here we have that original function, the one that we've been thinking about, y equals f of x, and f of x is x squared. Okay? So most of these are pretty easy. The only ones, this is easy, you can tell the vertex, which way it's going and where the, and then just plug a point in or something. But the ones that are going to be a little bit more of a pain are these. Not a pain, just an extra step. You have to complete the square for these. So I'll go ahead and do that after. All right, let's do this one. So the vertex here is 4. This one will be in green. So the vertex here is 4, 3. So 1, 2, 3, 4, 1, 2, 3. Okay. And again, we could do that thing where we plug in a point on either side. We know it's going to be going down. So let's go ahead and do, or we can, let's plug in 0. It's always kind of nice. So when we have 0, 0 minus 4. No, I'm going to do what I was doing before. Sorry, I just like the way it looks better. So we're going to go ahead and do 3. 3 minus 4 is negative 1. Negative 1 squared is 1 times negative is negative 1 plus 3 is negative 1 plus 3 is 2. So we had 3, 2. And I think this, is this the function that we ended up with last time? No, not quite. Doesn't have the 2. All right, and then if we were to do 5, we would know it would mirror it. So with 3 points, we can get a relatively accurate parabola. So the green is g of x equals negative x minus 4 squared plus 3. You can see it up there. It kind of cuts the page off. Okay. Next, h of x. Same deal here. So I'm going to skip B because you should understand it relatively good at this point. I'm going to go ahead and go to C where we complete the square. So kind of same process as before. I'm going to pull a 2 out And I'm going to go a little faster this time since we already did a complete the square. All right, plus 2 minus 4, because that's 4. We get 2 x plus 2 squared minus 2. All right, so we have our vertex here, which is 2, negative 2. Let's go ahead and plug in 1. That makes 3 squared is 9 times 2 is 18. Minus 2, oh, that one's a pain to graph. Well, oh well. Didn't see, did I do that right? 1 plus 2 is 3, 9, 18 minus 2. What I did is, maybe we'll do 0 instead. Let's see if that number is nicer. So, yep, 0 plus 2, you get 2 squared is 4, times 2 is 8, minus 2 is 6. That's better. 0, 6. And then we know we'll have a point that mirrors that, so it's over 2. Right, because there's always an axis of symmetry, so we know that it's always gonna, if you can find one point, you know where the other one is. If you know where the vertex is, and you know where one point is, then you always know where the mirror image point is. Okay, that's, not h, k of x equals 2x squared plus 8x. All right, and with that, you should be able to complete the homework. So message me if you have any questions, send comments.